Alright, so this should be a reasonably light section. It's on histograms, which are bar graphs, and frequency polygons, which are line graphs, and then we'll use the graphs to answer some questions. I think we get circle graphs in here, but none of what we do is rocket science. So I'll just jump into it, and hopefully this isn't a horrible mess. So first example, make a histogram from a frequency distribution. So in the last section we learned how to make frequency distributions, just the 2-column tables. You'll notice I didn't take the time to write the total on the bottom of this. It probably would have been nice if I would have put a total column, a total row, and whatever those add up to. 19, 37, 48, 58, 64. Probably would have been nice if I had that on there, but it really doesn't matter. And for making a bar graph or a histogram, it absolutely doesn't matter because the total doesn't show up in the histogram. So a histogram is just a bar graph, and I guess we'll learn how to make it here in a second. Oh, and when I make my bar graphs, I make my bars go vertically. It really isn't wrong to make your bars go horizontally. And to make a bar graph, I'm going to create an X and a Y axis, but just the first quadrant. So I'm going to make just, essentially an X and a Y axis, first quadrant. And I'm going to label the X and the Y axis with the headers from my frequency distribution. So the X axis I'm going to label number of children, the Y axis I'm going to label number of families, and when I get into, when I have a little more room, I'll write that in. Just do it. So beneath the X axis I'm going to write number of children, and actually far beneath, because I need to get some numbers under the axis too, and then number of families on the Y axis, just because that's how the points are, that's how the table was constructed, the kind of the X column and the Y column. So I'm just kind of simulating, graphing. And then I need to shove numbers beneath the each of the columns, or beneath the X column and along the Y axis as well. And when I go to write the numbers on the X axis, because the numbers are separated by 1 and they just go from 0 to 9, I'm going to write each of the numbers down. When I go to do the Y axis, it wouldn't be wrong to start with 1 and go 1, 2, 3, 4, 5, 6 all the way up to 18. That would require writing 18 numbers on the Y axis, and that might get kind of hard to read. So a lot of times I increment my Y axis by 2, 5, 10, 100, just to make the Y numbers a little easier to fit. And for this problem, I'm incrementing my Y axis by 5. So when I finally get to the graph, on my X axis you're going to see the numbers 0 through 9, but on the Y axis you'll see 0, 5, 10, 15, and 20. Rather than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 18. There's a lot of flexibility when you make bar graphs or histograms. There isn't a universal, this is the way this should be done based on how the data is given. And so there's definitely the probability, a good chance, that you make a histogram that's a little bit different looking than mine, and that's completely okay. So let me get into making the histogram. I had Excel make my histogram. So what Excel essentially did for me is kind of walk through what I said I was going to do, although it incremented the Y-axis by 2. So I incremented the Y-axis by 2 as opposed to 5, which isn't any more or less correct, it's just different. So on the X-axis I wrote the number of children. Next to the Y-axis I wrote the number of families. And then on the X-axis I wrote the numbers 0 through 9. On the Y-axis I wrote the numbers 0 through 20, incrementing by 2. And then above each number on the X-axis I just simply went up to the proper height. So for having 0 kids, I went up to a height of 8 and made a bar. For 1 kid, I went up to a height of 11, which is somewhere halfway between 10 and 12, and made a bar, and just did it all the way out for each of them. And then I made bars. To to make a histogram. This is how Excel decided my histogram should look. I'm not that gifted with making histograms on Excel, and there are definitely ways to customize the histogram to make it appear differently. A lot of times the individual bars in the histogram touch each other. If I knew how to do that, I kind of like that better. I would have made that happen, but I don't know how to make Excel do it. And clearly, if this is the default setting for Excel, it's a perfectly acceptable histogram. So I could have, when I was drawing the bars, made them, look like that. And probably if I was doing it by hand, I would have made them touch. Well, you can't even see. Well, if I was making a histogram by hand as opposed to using Excel to do my histogram, my bars would be touching like that. But I'd still have the same numbers along the x-axis, the same numbers around the y-axis, the same words beneath the x-axis and to the left of the y-axis. So it's just a bar chart, and that's really not so hard to do. The next thing's going to be equally not so hard to do. The next thing I'm going to do is construct a frequency polygon, and a frequency polygon is just a line graph that instead of making bars, you connect points with lines. So this is not going to be a big step. So the next example, I'm going to do a frequency polygon. A frequency polygon is just a line graph. If you laid my frequency histogram and frequency polygon on top of each other, they're going to look a heck of a lot alike. The difference between the polygon and the histogram is that instead of making bars, you have dots, and each of the dots is connected with a vertical line. More often than not, if I'm asked to make a histogram and a polygon for the same data, I usually draw them on the same graph. So I could have taken the graph that I used for the histogram and made a polygon on it by just going, for 0 kids, there were 8 families. For 1 kid, there were 11 families. For 2 kids, and so just make a dot where the top of the bar would go, and then connect the dots with straight lines or something that's reasonably straight. This is my school ID. Definitely wouldn't turn it face up, but that's what I had handy right now to do this. So if this was a test question, more than likely on the test question that involves histograms and frequency polygons, I'll give you a frequency distribution, which is a 2-column table, and I'll say construct a histogram and a frequency polygon. I expect most of you to do them on the same graph. You can do a separate histogram and a separate polygon, and you'll notice that the histogram that I just drew, if you look at this, they look essentially the same. They're exactly the same, other than Excel does a heck of a lot nicer drawing than I do. So it's completely okay to just sandwich them on one graph. But if you didn't want to sandwich them on one graph, then you could have your separate histogram or bar chart, and then essentially do the same thing. Just instead of drawing a bar at the height that needs to be, make a point and connect the points. So a polygon's just a line graph, and it shows the same information that a histogram shows. The x and the y-axis could have exactly the same labels. Alright, so now homework. So this is your homework. Looks like these aren't the same problem. It is what it is. So so this wants you to just make a frequency distribution from this. It wants you to make a histogram, or frequency histogram, those words are interchangeable, and a polygon graph, frequency polygon, for this. So you're going to make a bar chart and a line graph, and I probably should put them both on the same graph like I tried to show. And then when you get done, you can flick back to the end of this section to see what an answer looks like. And my answer, I don't know if I have separate or not, because when you're working with Excel, well, I'm working with Excel, my skills are limited. So when I made my graphs for this problem one, I did the frequency histogram and polygon separately. You certainly can show them on the same graph. So I'll do number 2, and for my graph, I hardly have the room to show this. On the x-axis, I need to go from 1920 to 2000, and then on the y-axis, I have to go from maybe 0 to 10%. I'm going to increment my y-axis by ones, do 0%, 1%, 2%, 3%, all the way to 10%. Then I'll kind of guesstimate where these percents go. They're not going to be very exactly placed, but that's where, if we need the exact, then we'll take the Excel answer. And on my x-axis, I'm just going to physically put these numbers. So when I go to do my histogram for problem and my polygon for problem 2, leave myself a little more room. Told myself to bring a ruler this morning, and of course I didn't. So when I go to make a histogram and or a polygon, usually I put my labels on my axes first. My x-axis is going to have a label that I'm going to call year, and my y-axis is going to have unemployment rate. I'm going to say in percent because I'm not going to write the percent symbol down with the number, just so you can't see what I just wrote. But I wrote unemployment rate in, and then probably parenthetically in percent because I'm not going to write the percents. On the x-axis, I'm going to take the numbers 1920 all the way up to 2010. When you're having Excel make the graphs, then having this many points isn't a nuisance, because you can just kind of shade all the points and then Excel draws the graph for you. When you're doing it by hand, having this many points to plot is kind of ridiculous. You'll notice that I'm trying to make my little marks on my x-axis equally spaced, but quite honestly, you're not, if you're not using a ruler, they're not going to be perfectly equally spaced, but that's completely okay. So that's a reasonable x-axis for the numbers in my x-com. My x-axis doesn't have to be like a regular x-axis on a XY coordinate system. In my y-axis, I'm going to go from 1 to 10, or even 0 through 10. I'll make 0 at the very bottom, and then 1 all the way up to 10. And I'm not going to want to redo this, so I'm going to draw my histogram and my polygram simultaneously on this graph. So now I need to plot points. The first point is the point 1920, 5.2%. So I go from 1920 and then up slightly higher than 5. I'll make a dot, and I'll do my polygon and histogram kind of at the same time. So now I'm just going to plot each point. So above 1930, I go to 4.2%. So 1930 up a little bit above 4. 1940, 8.7%. And again, these are just estimates. I went somewhere between 8 and 9, tried to get a little closer to 9 than I did 8. 1950, 5.3%, should be a little bit higher than that. And it should be above the 1950. 1960, 5.5%, so it should be just a little bit higher than that, but lower than 6. And it should be actually above the 1960. 1970, 4.9%, which is higher than this 4.2%, so I don't, best I can. This is not rocket science when you're not having any graph paper to, any grid paper to make it. You're just kind of estimating where the points go. 1980, 7.1%, maybe about there. 1990, 5.6%. You know, again, if I wanted something perfectly accurate, I just use Excel. 2000, 4%. Not the best data because it's so bunched up. In 2010, 9.6%. So best I could, I plotted the points, and now I'm going to make my frequency polygon first because the points are, I kind of destroy the points a little bit when I make the histogram. So each of the points I'm going to connect. And this will be called the frequency polygon. Tedious to say the least. So I'm going to say frequency polygon in black. I don't know how well my red's working this morning, but my histogram is going to be in red. And you can call it a frequency histogram, or you could just call it a histogram, and you don't need a little table like this at all. Now I'm just going to make bars that connect the dots. The bars can be connected or they can be separate from each other. Since Excel makes them separate, I'll try to make them separate. So I'm going to make a bar that kind of straddles the 1920 that goes up to the dot, and then a bar that more or less straddles the 1930 goes up to the dot, a bar that goes around the 1940 up to the dot. These are supposed to actually be straight, but again, this is, if I want perfection or something that's even reasonable, I bust out some sort of program. And the only one I have that I know how to use is Excel. So I'm just making a bar that goes up to each of the dots that has the dot, you know, more or less in the middle of the bar, top of the bar. And it's nice if each of the bars has the same width. God, that sounds wonderful. So that's what I'd probably expect on a test. There's likely on the test going to be a question that gives you one table, or frequency distribution, and it asks you to make a frequency polygon and a frequency distribution, or a histogram, and I usually do them on the same graph. Again, I don't know how to make Excel do the two graphs on the same graph, so all my keys to this, all my answers to this, will have them on separate graphs. But you can do separate graphs if you have the time to do that, or you can show them together like I just did here. For the next two problems that we get to do, problem 3 wants you to do both, again, a histogram and a polygon. And you're most welcome to just, on the x-axis, write the physical. I'm going to write 16 to 22, 23 to 29, and so forth. So when you go to start your x-axis, I'd probably kind of horizontally, you know, make a room for 16 through 22, make a room for 23 to 29, and so forth. Underneath this, I'd probably write income, because that's what the x-axis is titled. And then on the y-axis, I'd write number of families. And then on the y-axis, you can increment by 1. You're not showing the total, and you only have to go 1, 2, 3, 4, 5. So that's really friendly data to plot. So that shouldn't be too hard. You can do a polygon and a histogram from this data, and I'll do my kind of sister problem and make my polygon and my histogram. And I think I can shove it right on here. So I'm going to make that effort anyways. So my x-axis has to have room for those classes. And I think I can get those in pretty efficiently. My y-axis needs to go a little bit higher than your y-axis, or at least has more numbers on it. So My x-axis, beneath it I'm going to write class because that's all that's written above the x column. To the side of my y-axis I'm going to write frequency. On my x-axis I'm just going to make little marks. First mark I'm going to call it 40 to 49. The second I'm going to call it 50 to 59. And then 60 to 69. 70 to 79, 80 to 89, and 90 to 99. And then I'll start making my dots. Well, I better get my y-axis. So zeros down here, then 1, 2, 3, 4, 5, 6, 7. So first class 40 to 49 goes up at 7. 50 to 59 goes to 5, much nicer data to plot. 60 to 69 goes up to 3, 70 to 79 at 2, 80 to 89 at 7, and again I'm not being super precise in plotting these, and 90 to 99 1. I'll just connect the dots that I make, and that would be called my frequency polygon. And then I like to pull out a different color to do the histogram. So there's more or less my frequency polygon, a good enough frequency polygon for this distribution. And then I'm going to make my histogram. This really horribly sounding pen. Again, I'm being consistent with what Excel gave me in terms of having not the bars connected. Hardly care if you connect the bars. The bars are touching, it's completely fine. So again, that's both things shown on one graph. I'm not even writing a little code this time. I think it's obvious that what the polygon and what the histogram is. All right. The next thing that we need to make is our stem and leaf displays. And stem and leaf displays are, in some sense, bar graphs written horizontally with the numbers shown. And I don't know how good this sheet is, this page is right here. But basically, we're going to take numbers and we're going to break them up. A 2-digit number, we're going to break up the 10 and the 1 separately. The 10's part, 50 part, we're going to call the stem. The 1's part, we're going to call the leaf. 3-digit numbers, we could break it up into 2 parts. The 48, which is the hundreds and the tens, could be called the stem. The 3 could be the leaf, or the 4 from the 400 could be the stem. The 83 could be the leaf. Most of everything we're going to do are 2-digit numbers, so it's not going to be hard to break them up. And then a 1-digit number, there's only 1 digit, and usually that's thrown in the leaf, and you put a 0 when there isn't a first number for the stem. This may not make a lot of sense, but once we do the problems, it'll make more sense. Again, this is another one of the concepts where the rules aren't hard and fast. So usually in math, the rules are just what they are, and you can't stray from the rules. But making visual representations of data, the rules are really loose. So it's hard to say this. It's almost harder to teach when you have that flexibility. So here's an example. So at this table of data, it represents the ages of 20 guests at 4 p.m. when happy hour starts at the Yard House. A stem and leaf display has been started. Finish the stem and leaf display. It's interesting. My niece is staying with me now for a couple weeks over Christmas, and she grew up in Massachusetts, moved to Texas, and in Massachusetts, it's illegal to have happy hours since, I guess, apparently since 1981. There hasn't been a happy hour in Massachusetts, so she didn't even know what happy hours were until she moved to Texas. Thought that was really interesting, and now it came up here. So, anyways, so I took the numbers and I broke them up into tens. I broke them up by 10. So I did the 20s, and I put a 2 for the 20, and then I did a stem for 7, 8, and 9. And then I took the 30s, 31, 32, 39. This represents 30, and then there's 31, 32, 39. So this says 27, 28, 29, 31, 32, 39. I'm going to do the same thing for the 40s. So I'm going to have 43, 44, another 44, you need to write the duplicates, a 45, and a 47. And then for the 50s, 50, 56, 58, 59, and for the 60s, 60, 62, 68, and for the 70s, 71 and 72. So this would be called a stem and leaf display or a stem and leaf plot. And like I said, it's kind of a histogram on its side, because if you put it there, you can almost see the bars that would come up in a histogram if you're plotting the data. And the first class maybe was 20 to 29, the second class was 30 to 39. So it's kind of showing the same information that a histogram shows, just a little bit differently. And from a stem and leaf display, you can see all the data that makes up the stem and leaf display. So it's kind of nice. It doesn't destroy the data like a histogram does. And it says here that the leaves don't have to be in ascending order, but I don't think I've ever seen a stem and leaf display when the leaves weren't in ascending order. Alright, so now we get to do our homework. So you're going to make a stem and leaf display for this data, and you'll look at when I did my stem and leaf display, I didn't get that wordy in terms of labeling the columns. I just called one stem and one leaf. So when you do yours, you're going to take the tens and put them in a column called stem. Then I usually put a vertical bar and then make a column called leaves. I leave a little gap between. I guess you don't really have to leave a little gap between, but I want to be able to really separately see the stem and the leaves. And then just put the numbers, the ones parts in. So that's your data. You can pause and do this. I'll go do mine. And in mine, I'm going to have to do a 0. So this is 20 workers at a local mall were asked how many miles they commute to work one way, and here's the table. So for my stems, because I have some numbers that don't have a tens position, I'm going to have to put a 0 for the stem for the first couple. And get my vertical bar. So next to the 0, I'm going to put a 1, 3, 3, all these, oh gosh. So I'm going to get a 1, 3, 3, 7, 7, 8, 9, and 9. And then my tens are going to have a 10, 11, 10, 11, 13, 14, 14, 15, 17, 18. And then my 20s are going to have 20, 21, 21, 23. Make sure I have all the data in. So there should be 20, 1, 2, 3, 4, 5, 6, 7, 8, 16, 20. So I have all the data in. So that would be as nice of a stem and leaf plot as I really care to do right now. And since I always need both a stem and a leaf, 1-digit numbers less than 10, you're going to put a 0 for the stem, and then the leaf can be the ones part. And then I don't do a lot of stem and leaf displays, but they probably don't work so nicely for data that has decimals or fractions. You probably would never be asked to make a stem and leaf display unless the data was all nice integers. Alright, so you get another problem that you get to make a stem and leaf display for. And your first stem could have a 4, your last stem could have a 7, and then you can pause the video and rip out your stem and leaf display for this starting salaries of recent computer science majors. and then I'll do mine. All right. 15 students were asked how many times each week they ate fast food. Dang, really? I'm sure I made these numbers up. So I'm going to need a stem that has a 0, and I'm going to put a 0, 1, 2, 4, 4, 5, 8, and then the 10s are going to have 11, 11, 13, 14, and 15, and then the 20s are 0, 1, and 2. So these are, I mean, easy to do. And, you know, I only gave us 2-digit numbers because they're just not that important, stem and leaf displays. I wouldn't be shocked if this doesn't make its way onto the review for the test. I don't remember. I wrote the review months and months ago, and I just don't remember what's on it right yet. Next concepts are circle graphs. Sometimes I call them pie charts. And we're going to be asked from a group of data to make circle graphs. And when you're making circle graphs, you kind of have to know how big of a slice of pie to make a specific region be. And I just tried to, on this, show you what, for a piece of pie, or for a circle, what some common sizes are. So 50% represents half the circle, and that 50% is half whether it's written there. So when we make a pie chart, we're going to break a circle up into essentially probably unequal slices of pie, and where you make your slice, where you make your cut doesn't matter. So 50% is half the circle, and then this region right here is a quarter of the circle, and a quarter of the circle is a piece that represents 25% of the circle. And then these two pieces that are half of a quarter are 12.5%. So this piece, as well as this piece, are both 12.5%. That's 12.5%. So we're going to be given data, we're going to be asked to make a circle graph, and I am not going to pull out any sort of tools to help me make my graph. So my graphs are going to be really not beautiful. But one thing I'm going to keep in mind is kind of relatively how big this piece of the pie should be, and I'll keep these in mind, and I'll keep these in mind. So this region right here is 10%. 10% is less than 12%. And then this whole region, I don't know why I did 90, and 10% must be something that comes up in a problem. But this whole region represents 90%. I'm not going to do shading on circle graphs because then it's hard to read them. Alright, so now I want to make a circle graph, and I say, for the most part, you know, I'm not doing these things that accurately. If I need an accurate graph, then I'm going to make Excel, make my circle graph, and all the answers that I have back in the keys for the problems in this grouping, I used Excel. And I'll talk about how Excel made the answer and how I'm going to make the answer by hand. They'll be slightly different. The numbers will be the same, but they'll be differently located. So I'm going to try to make a circle graph for this data. Quite honestly, if you have, you know, more than 4, maybe more than 5 pieces of data that you want to break up into a circle graph, your circle graph's going to be kind of hard to read. So we try to minimize the amount of data, or the number of pieces of pie that I need to cut the circle up into. You know, 4 or 5 is probably easy to read. 10 would be ridiculous. But again, there aren't any right or wrongs for most of the problems in this section. So this right here, 600 people were leaving a movie theater at Arrowhead, and they were asked what kind of movie they saw. Maybe they were asked specifically what movie they saw, and then they were subdivided into categories. And I want to make a circle graph that represents, of the 600 people, 150 saw action, 300 saw comedy, 75 drama, and 75 fiction. Inside my circle graph, I usually put percents. And so I'm going to figure out what percentage of the people saw action, what percentage saw comedy, which percentage saw drama and science fiction. I do that by dividing. So next to the action, I'm going to figure out what percent of the people that went saw action. And 150 of the 600 people saw an action movie. And if I divide 150 divided by 600, you get 0.25, and 0.25 as a decimal is 25%. So I'm going to make a region that's a quarter of the circle and label it action. And then for comedy, I'm going to go 300 divided by 600. The reason I'm dividing by 600 because these numbers add up to 600. This comes out to 0.5. Which is 50%. And the last two numbers, if I do 75 divided by 600, I think I'm going to get 12.5. So I do 75 divided by 600, I get 0.125. I move the decimal 2 over, and that's going to be 12.5%. So for each of the drama and the sci-fi, I'm going to make 12.5%. Now I'm ready to make my circle graph. So I know the relative sizes. The comedy needs to be half the circle, the action needs to be a quarter of the circle, and then these two, I'll take the remaining part of the circle and break it up in half, break a quarter up into 2 halves essentially. So I'll show that on the next pages. And so here's this page just shows the computations that I did, and I even took the time to say this percent column, 25% plus 50% plus 12.5% plus 12.5%, that has to equal 100%. If it comes out, almost 100% but not exactly, that's because of rounding. If it's far off from 100%, then you made a math error somewhere. So now I need to make these into a circle graph. And what Excel does, what I know how to get Excel to do is I know how to get Excel to draw the percents inside the circles, but I don't know how to make Excel make the words inside the circle. So it puts the words in a legend and it color codes, but you can't see the color. So if I was doing this by hand, the first thing I would need to put in is action, which is 25%. So somewhere's in this circle, from the center out, I'm going to make a quarter of the circle. And if I have room inside, I'd like to go right inside and write what the category is and what the percent is. I just don't know how to make Excel make the words go with the regions. The next thing I'm going to fill in is comedy, which was 50%, and so I'm just going to extend this bar on the bottom. I'm going to call this comedy and write 50% with it. And then the last two, both drama and science fiction, need to be 12.5%, and they're both the same size of each other. I'm just going to take the remaining piece of the pie, cut it in half, and then maybe make a little error here to say, I don't know, sci-fi 12.5%. So if what I need to write in this, you can't see what I freaking just wrote. If you can't see what belongs in the circle, you can put little lines. So this is my representation of what Excel did. you'll notice that Excel, it's 50% is here, it's 25% is there. There isn't, as near as I know, a incorrect or correct way to cut the circle up. The sizes have to be right. So 50% has to be half the circle, but it doesn't matter where you put that 50% at. Just as long as it represents the data accurately or reasonably accurately, we're going to be fine. And once we get into the homework, which is coming right up here, it's going to be, you know, if we're not plotting 50 and 25%, it's going to be hard to make something that's exact, and we just don't need to be exact. So in here I said make a reasonable picture, and it's definitely not going to be that great. All right, so this is your problem. So you're going to make a circle graph that has 5 pieces of pie cut out. First thing you're going to need to do is add up the numbers, so 50, 75, 85, 95, 100. And then you're going to need to turn each of the numbers into a percent. So you're going to go 50 divided by 100 equals 0.5. Drag the decimal over and get 50%. And then once you get each number into a percent, you'll draw a circle graph. For the iPhone, you're going to make 50%, so I might go like 50%, 50 iPhone. And then the best you can, make something that fits the other pieces reasonably well. The galaxy is going to be easy to fit in, and then the last 3 you'll just kind of fudge in the best you can. And the reason why I showed a 10% sector, because I knew in your homework you're going to have a 10% sector. So just to get an idea between a 10% sector and a 12.5% sector, they're not that different. 12.5% is a little bigger than 10%, but you know, not much bigger. And when you go to do yours, the important thing is something that represents 50%, that should be exactly 1/2. Something that represents 25% should be exactly 1/4. And then the rest of the numbers just relatively. The 2 10s should be about the same size, and the 5 should be the smallest size. So I'm not looking for, you know, perfect circle graphs. And if you can write the percent along with the word inside a circle, that's fine. If it doesn't fit, write it outside, make a line pointing to it. All right, so I made myself a 4 piece of the pie, so 40, 70, 85. So my numbers add up to 85, and now I'm going to make each of the numbers in the right column into a percent. So I'm going to go 40 divided by 85. That gives me about 47%, and I'm going to round to 2 decimals. I can't graph percents that accurately anyways. Just as long as my percents add up to 100, I'll be okay. And if they don't add up to 100, then I'm going to fudge a little bit. So let me add these up. So 47 plus 35 plus 12 plus 6 adds up to 100. So that's reasonable. This is a really unpleasant graph to need to make, but I wanted to give myself something that was, you know, a little bit challenging. When we get to the tests, I'd probably load it up with, you know, 25% and 50%. So what's going to be important when I make up my circle graph is that the region that represents IQs between 85 and 100 is the biggest, and the regions that represents IQs bigger than 130 is the smallest. So relatively, the relative sizes are important. And this one right here is just slightly less than 50%. So if I just took a bar that was 50% and just made it just a little bit shorter, put a little bend to it, I can call that 47%, you know, and maybe that's more like 43%, but it's okay. So I'm going to, in this one, going to write IQs between 85 and 100, and I'm going to say 47%. It might be nice if I called this IQ, but not going to be that picky. Now for the next one I need 35%. If I went straight down from this, I'd get a quarter. And then I need to add another 10%. So I'm going to maybe do something like this. That's a quarter plus something that's about a 10%. That's actually probably like a quarter plus 12%. But again, it's good enough. It's something that's reasonable. There's 25%. That's a reasonable 10%, probably a little bit too big, but it's okay. And so I'm going to call this 100 to 115, and I'll call it 35%. Again, if I'm looking for an exact, beautiful circle graph, I'm not going to freehand it. I'm going to use some technology and it will do it exact. So when I'm working by hand, I limit it to, you know, my visual and my drawing abilities and my spatial abilities. Now this region needs to be brought up into a 12% and a 6%. So I'm going to break it up into a small and a big region. I'm going to call the big region 12%, and that's probably bigger than 12%. That's probably like 14%, but I don't care. It's close enough for my purposes in that it's close-ish. And the thing that shows up in my circle graph is the 47% is the biggest, the 35% is the second biggest, 12% is the third largest, and the 6% is the smallest. Then I got lazy. I didn't feel like writing higher than 130, so I wrote 130 plus and wrote 6%. That's okay too. So this is, you know, good enough for test purposes. Again, you would, anytime you were, if you're trying to show a circle graph to somebody, you would just use technology to rip that out. So you get another circle graph, and I've tried to make the percents easy. So I'll let you, pause the video for a second, finish up problem 11. And we're done drawing pictures, which is really kind of a relief for me because I'm drawing and me just, don't work well together. And we'll go into answering questions about from the graphs that we've drawn, or graphs that are similar to what we've drawn. So here's a circle graph, and this circle graph represents 200 people, and 200 people were asked what their favorite sport were, and these are the breakdowns. Again, this is probably a graph that I found from Google Images, and then I tried to make up some words that went along with it that didn't seem ridiculous, but I doubt if you ask 200 people that 13% of them would say their favorite sport is badminton, at least not in the US. Nevertheless, this is what this data represents, or what I said it represents. So now I'm going to answer questions about this. How many of the 200 people that were surveyed, how many of them said their favorite sport was tennis? Well, 18% of the 200 people said their favorite sport was tennis. So 18% of means multiply. So if I take the 200 people and multiply it by the 18% that said that's their favorite sport, then I'd get 36 of them that would say that tennis is their favorite sport. Most of the word problems, we're going to have to multiply to get our answers. Second question, how many more people favored soccer than basketball? Well, I need to find out the number of people that favored soccer, and the number of people that favored soccer would be the 29% that like soccer as a decimal, which is 0.29, times 200. And that would give me 58 people said soccer was their favorite. And then for basketball, I'd go 22% times 200 and get 44 people said that their favorite was basketball. Notice there aren't any footballs, baseballs, clearly wouldn't be America. And then the difference, how many more people favored soccer than basketball? I'll take the number of people that favored soccer, 58, minus the number of people that favored basketball, 44, and subtract, and you'd get 14 more people favored soccer than basketball. And that's what I did on this sheet. Is exactly what I did. I found the number of people that favored soccer by just multiplying the total number surveyed by the percent as a decimal, did the same thing for the basketball, and then I subtracted the amounts. All right. right, so now homework problems. I get to do number 12 because it's even. So it talks about Andrew. Hopefully I'll blow it up a little bit to find it, make it as readable as it can. So Andrew spends 25 hours a week doing leisure activities, and here's what he does: plays drums, video games, sports, TV, and reads. So how many hours a week does Andrew spend watching television? Well, he spends 20% of his time his leisure time watching television of the 25 hours. So I'm going to take the 25 hours that he has available for leisure time and multiply it by 20% as a decimal, which is 0.2. I think that's just 5. I don't know why I say round to 2 decimals. But I'm going to do that on my calculator because I know I make mistakes, and trusting myself to do it in my head is not always the smartest. So he spends 5 hours per week. And then much more time does Andrew spend playing sports than reading? Well, for sports, I'll figure out how many hours he does playing sports. For sports, he's going to take the 25 total hours times the 25%. This I might need to round to 2 decimals. That's 6.25 hours playing sports. And then for reading, it's 25 hours times 15% as a decimal. That's 3.75 hours. Now if I subtract these, this will give me how much more he does with sports and reading. So Andrew's definitely well-rounded. I get 2.5 hours. So the answer to part B is going to be 2.5 hours. Maybe 2.5 hours more if I wanted to be more precise, but that's good enough. So now there should be a similar problem for you to do. It's not as readable here. So a survey was given to 500 students, and they were asked what their favorite music was, and most everybody picked pop, so it's 64% there for the pop. That wasn't readable in there. I think it's readable, but I can't tell. And so from this, how many students said their favorite type is country, and then what's the most popular type of music, and how many students say it's their favorite. So hopefully you could do those without my guidance. You won't have to do a subtraction one like I did. So you can pause it and do it, and I'll move on to mine. This is not going to be that readable, so because I have a hard time with the circle graphs getting the words to line up, and if it's not in color, it's hard to read, I took the information that's in the circle graph and told you what it broke down to. So this circle graph represents the 320 million people that currently live in the United States and breaks them down by age. So it says between 10% of the people are between 0 and 17 years old. 30% of the people in the U.S. are between 18 and 44 years old. 40% of the people are between 45 and 64 years old, and 20% are older than 65. That's what this circle graph represents, but in black and white, it's not that readable. So, question 1, how many people are 45 or older? Well, the people that are 45 or older are the ones that are 45 through 64, and the ones that are 65 and older. So that represents 40% of the people that are 45 to 64, and another 20% that are 65 or older. So 60% of the people in the United States are 45 or older. And how much is that? Well, there are 320 million people in the United States. So if you take the 320 million people, multiply it by the 60% as a decimal, that will translate that to a number. So now I'm just going to go 320 million times 0.60, and that's going to give me 192 million people in the United States that are 45 or older. And then how many are 45 or under? Well, this 10% are 45 and under. That 30% are 45 and under. So I'm going to take the 10% plus the 30%. That's going to give me 40% that are in that age bracket. And now I'm going to take the 320 million and multiply it by 40% as a decimal. And there are other ways to get that answer. That's just the first one that came to my mind. And it's consistent at least. I get 128 million. So there are 128 million people that are under 45. And again, I think these numbers are right because I probably just researched that on the net. Again, right at least for now, and maybe 10 years from now they might not be so right. All right, so that's my problem. It means you get a problem like this. So 300 people attended a concert, and we grouped their ages. So 10% were bigger than 50, 34% were between 13 and 39. Same basic question that I did, just for your data and your circle. So I'll give you a second to pause that and do the problems. Flick to the back to check your answers. Now I'll do mine based on a bar graph. A little bit different than a circle graph. I'm not going to have any multiplying. This is mostly going to be adding. So I need to understand what this frequency histogram represents in problem 16. So this is the salaries of employees in a certain company. So looks like the lowest salaries are between $11,000 and $21,000 per year, and 300 people made that. And then between $22,000 and $32,000 per year, I guess I'm going to call that $250,000, but oh gosh, is that exactly halfway? It's pretty close to exactly halfway. So I would say about 250 people have those salaries, and then 400 people have salaries between $33,000 and $43,000 per year. I'll call that 550 people have salaries between $44,000 and $54,000, and so forth. So, question A, how many employees made at least $44,000 per year? That's going to be all these employees. Employees that are represented by these bars make that for a salary. So I need to find out how many employees this represents. This bar represents 550 employees, so they need to be counted. This bar represents 450 employees. They also need to be counted. I'm going to add those to the 550 that have to be counted. This represents, I'm going to say it's 250. And that's my best guess. I mean, in this I'm going to call 350. Again, your answer is only as good as the graph, or as well as you can interpret the graph. So I made numbers of people for each of the salary ranges that fit at least 44,000. Now I'm going to add these together. So it's 1,006. I think it's 1,700. So my answer to question A should be 1,700. I'm going to double check that by yanking out my calculator and adding these numbers. So I'm going to go clear it out. 550 plus 450 plus 250 plus 350 plus 100. And I get 1,700 people. How many people made less than 33,000? That's these people. There's 0 and there's no bar there, so there's 0. I'm going to say that bar is at 300 and this bar is at 250. So I would add up the 0 plus the 300 plus the 250. I'm getting 550. Probably would be nice if I said 550 people make less than 33,000 per year, but I could live with just the number. Maybe with the words people next to it might be a little bit better. All right, so this is yours. I'll try to blow it up. So this is, so there was an assembly at a school, and these are the ages of the students that were in attendance. How many people were at least 15, how many people were under 12, and I'm not sure how well this is going to show up. So For 8 years old, there were 10 people. For 9 years old, 20. For 10 years old, 40. 11 years old, there were 60 people. 12, there were 80 12-year-olds. 50 13-year-olds. 40 14-year-olds. Oh, idiot. 40 15-year-olds. 20 16-year-olds, and 10 17-year-olds. So those are the heights, the best if they weren't that readable. Not that my numbers are going to be that readable. And then how many people were at least 15? Well, at least 15 would count these. And then how many people were under 12? That would count those. And you just need to add up the heights of the bars. Okay, so we've got 18, 19, and that's it. Just one more for me and then one more for you. So 18 gives me the breakdown of the grades on a test. So 12%, 200 students took a test, 12% got A's, 29% got B's. What an idiot of a question. What percentage of the students got an A on the final exam? That's a silly question. 12%. I mean, there's no work to do for that, but I'll live with it. How many students got an A on the final exam? Well, 200 students took the final exam. If you multiply that by the 12% as a decimal, that's going to give me 24 students got an A. And how many students failed, got a D or an F? Well, 10% got a D, 16% got an F. So 10 plus 16 is 26% of the students failed. And if you do 0.26 times 200, you'll get 52 students failed. Again, if you're considering a D or an F failing, and I usually consider that. Some students don't find D's failing, but I always think D is a failing grade. So that's the end of my work. Now you have a problem, and this gives you the height of 300 men in inches. And let me blow it up and try to, I think it's going to be obvious hopefully that's obvious. So the best I can. So the numbers on the x-axis are the heights. So 63 inches, that's what, 5 foot 3 inches, 5 foot 4, 5'5", all the way up to 6 foot 2 inches. So of the 300 people that were surveyed, 2 were 5 foot 3, 300 men that were surveyed. 3 were 5 foot 3, 4 were 65 inches, that's 5 foot 5, should I say. And then, I don't know, there were 18 that were 71 inches, that's 5 foot 11. There were 11 that were 6 foot or 72 inches, 4, 3. So hopefully all the numbers are readable on here. Between 68 and 70, this is a 10, 12, 14. So the first question said how many people had heights between 68 and 70 inclusive. So you're going to count these guys. I don't like my question to part B. Let me look at my answer to part B of 19 because I'm almost surprised when I read that. Yeah, let's change this to how many. So that's what I answered. So for part B, how many men had heights greater than 72 inches? And hopefully this is readable enough that you can get that without having to print something out. All right, so first question, how many men had heights between 68 and 70? Second, how many had heights greater than 72 inches? All right, so should be done with that. The next 3 sections in chapter 3 are the 3 sections in this class that you need this calculator, or a calculator that is similar to this. The TI-83 would be fine. Casio calculators, Casio graphing calculators generally have the abilities to do everything we need in the next 3 sections, but quite honestly, I have no idea how to use them, so you'd be completely on your own. So I hope you can at least borrow one for the next few days.